Dear friends, we are going to discuss the most important topic of this decade, nanotechnology and its applications. The word nano is derived from the Greek word and it means draft. It is smaller than 1 micron or 1 million of a millimeter. It is equal to 10 power minus 9 meter. The idea of nanotechnology was born in 1959 when physicist Richard Feynman gave a lecture on exploring the idea of building things at the atomic and molecular scale. Nanotechnology and nanoscience got a boost in the early 1980s with two major developments: the birth of cluster science and the invention of the scanning tunneling microscope. Let us see some of the applications of nanotechnology. Chemical catalysts and filtration techniques are the two prominent examples where nanotechnology already plays a role. All chemical synthesis can be understood in terms of nanotechnology because of its ability to manufacture certain molecules. Chemical catalysts benefits especially from nanoparticles due to the extremely large surface to volume ratio. The application potential of nanoparticles in catalysts ranges from fuel cells to catalytic converters and photocatalytic devices. Nanofiltration is mainly used for the removal of ions or the separation of different fluids. Using nanoscale particles increases the efficiency of observing the contaminants and is comparatively inexpensive compared to traditional precipitation and filtration methods. A reduction of energy consumption can be reached by better insulation systems by the use of more efficient lighting or combustion systems. Nanotechnological approaches like light-emitting diodes or quantum-caged atoms could lead to a strong reduction of energy consumption for illumination. Today's best solar cells have layers of several different semiconductors stacked together to absorb light at different energies, but they still only manage to use 40% of sun's energy. Nanotechnology could help increase the effectiveness of light conversion by using nanostructures with a continuum of band gaps. The most prominent nanostructured material in fuel cells is the catalyst consisting of carbon-supported noble metal particles. Nanotechnology can contribute to the further reduction of combustion engine pollutants by nanoporous filters, which can clean the exhaust mechanically by catalytic converters based on nanoscale noble metal particles or by catalytic coatings on cylinder walls and catalytic nanoparticles as additive for fuels. The use of batteries with higher energy content or the use of rechargeable batteries or supercapacitors with high rate of recharging using nanomaterials could be helpful for the battery disposal problem. The dependence of the resistance of the material on an external field is called magnetoresistance. This effect can be significantly amplified for nanosized objects. For example, when two ferromagnetic layers are separated by a non-magnetic layer which is several nanometers thick. One of the major applications of nano-optoelectronic devices is a quantum dot laser. The advantage of the quantum dot is that its emitted wavelength depends on the diameter of the dot. They are cheaper and offer a higher beam quality. The production of displays with low energy consumption could be accomplished using carbon nanotubes. Carbon nanotubes can be electrically conductive, and due to their small diameter of several nanometers, they can be used as field emitters with extremely high efficiency for field emission displays. The principle of operation resembles that of the cathode ray tube. Nanoscale devices exhibit dominant non-linearities that prevent their use as two-state devices in digital computers. The idea behind nanologic is to exploit these non-linearities to implement functions that correspond to mathematical sets: interval numbers, disjoint intervals, Bussy numbers, Bussy sets. Simple nanoelectronic circuits can be designed that can represent sets and set operations, and an array of such devices constitutes a universal mathematical procedure able to solve any problem that can be expressed in set theory. Other than the above mentioned applications, some of the other applications include aerospace, vehicle manufacturing, consumer goods, food, household, optics, textiles, and cosmetics. I'm happy that you have gained some knowledge about nanotechnology and its applications. Thank you.